We're talking about the mandatory safety assessment in the new Toy Safety Directive. And well, I have about 30 minutes to go through the safety assessment, and of course this covers all the hazards a toy could present, and it's not possible to go into all the details, so I'll try to give you an overview. But there is a requirement to perform a safety assessment, and this also includes chemical hazards. And it's important there to note that the requirement to perform the safety assessment for chemical hazards is in place already since the 20th of July 2011, even though the actual chemical requirements do not come into force until the 20th of July 2013. So it's the manufacturer that has the obligation to draw up the safety assessment. And he cannot delegate this obligation to any other operator, not to the importer or the distributor. And also it's important to notice that it has to be carried out before the toy is placed on the market. And the aim is to identify and to minimize the risks that the toy may present before placing it on the market. And we have already received information about the various guidance documents, and there's one very extensive guidance document available on the link that's on this slide. It's up to the manufacturer to decide when the safety assessment is carried out, as long as it's done before placing it on the market. But the earlier in the design process or the development process it's made, the easier it will be to correct any risks or mitigate any risk that you might find. The safety assessment will be easier the more knowledge you have. For example, a good knowledge of the applicable standards will make it easier to quickly determine whether or not a specific hazard is covered by those standards. So you will need knowledge about the toy. How is it used? By whom is it used? That's the age grade. Which materials are used and which substances are used. You need knowledge about the applicable standards, knowledge about any restrictions that might apply to chemicals or certain substances. You need knowledge about emerging issues. I mean, long before standards and regulations are changed, we usually know that a new hazard has arisen. You need to keep in touch with various sources of information. You also need knowledge about hazards, of course. And then the ability to identify hazards and to evaluate risks. Now, to identify hazards, and also those that are emerging, you can refer to your own experience. You will have experience from previous productions. Consumer complaints, the recalls made in Europe on the RAPEX system or on the CPSC website. You can check requirements in other standards. We have an ISO standard, the US standard, and they sometimes contain requirements which are not contained in the European standards, and they might be useful. Then you have newsletters, trade association information, the guidance documents from the Commission, etc. And when it comes to identifying hazards, you should also be imaginative. Try to really consider how can this toy be used. Unusual play patterns, unusual play environments, etc. Is it used indoors, outdoors? And in general, you're permitted to use third-party services to assist you with the safety assessment, but you're always responsible for its contents. I've divided the safety assessment into 3 sections. The first one would be the mechanical, physical, flammability and electrical hazards, because for these hazards we do have the harmonized and reference standards that Maureen mentioned. And we also heard that we have 2 basic ways for the conformity assessment, either the self-verification or the use of a third-party verification, a notified body. But if we do have harmonized reference standards in place, we can use those for the self-verification procedure. So in these cases, mechanical, physical, flammability and electrical hazards, where we do have these harmonized reference standards, the purpose of the safety assessment is basically to ensure that there are no hazards present in the toy which are not covered by these standards. The next section will be hygiene and radioactivity hazards, where we do not have any harmonized standards. And we are not planning at present either to elaborate such standards, and therefore the safety assessment is used instead. So the purpose would be to evaluate compliance with the directives requirements. And then, of course, you might ask yourself why, for mechanical, physical, and flammability and electrical hazards, do we say that if there are no harmonized standards, you need to use the third-party verification and notify body? Why is this not the case with hygiene and radioactivity hazards? Well, it has been accepted that for certain hazards, harmonized standards are not needed in order to assess whether a hazard exists or not. And these hygiene and radioactivity hazards are examples of such cases. And at the same time, it's not uncommon that manufacturers will use third-party assistance to evaluate these hazards. The third section would be the chemical hazards. And here we do have some standards, but when we look at the new chemical requirements, we will not have standards for all chemical hazards. And therefore, in this case, the safety assessment is used both to ensure compliance with the standards, but also to ensure that other chemical hazards do not exist and lead to risks. So if we dig a bit deeper into the mechanical, physical, flammability and electrical hazards, where we have harmonized standards. The standards themselves can be considered as a form of risk assessments. There's been a lot of people around the tables writing these standards, and they have a lot of experience from toys, from hazards, from recalls. And therefore, the ambition is, of course, that the standard is always fully up to date and covers all hazards. However, they are written for today's products, which means that we don't know what type of toys we might see on the market tomorrow. They might introduce new hazards, and therefore the standards cannot always cover every single hazard. We have a good example, I think, with a magnet problem that came up a couple of years ago, where when the magnets were introduced, we did not realize that we were also introducing a new hazard, but it became obvious quite soon that the magnets were in fact a totally new hazard, and they were not addressed by the standards. So that would be a case when a new feature was introduced and at the same time a hazard which was not covered by the standards. So this is the outline of the safety assessment for mechanical, electrical and flammability hazards. Well, you first have to identify your toy. And we also heard that the description of the toy is in fact required as part of the technical documentation. And it would include information on age grading, warnings, packagings, instructions, etc. You need to describe the use, who is the user's ability and behavior, under which conditions is it used, what's the reasonably foreseeable use, what's the frequency, the duration of the use, all those factors that will have an effect. And then you need to identify the hazards. And the purpose is to establish that all these hazards are effectively managed by the standards. And you should document these things. It was mentioned that the technical documentation needs to include it, so this should be documented. You don't need to contain a list of all the hazards you have identified, but the hazards that have led you to an action to redesign or reduce or use a warning, those hazards should be documented. The next step is to identify which harmonized applicable standards do we have. And in the case of mechanical, electrical and flammability standards, it's easy. We have EN 71 series, part 1 for mechanical, 2 for flammability, 8 for activity toys, and then we have the standard EN 62115 for electrical hazards. And it's important that you have access to the latest versions. The standards are updated on a regular basis, and you need the latest version. You then ask yourself whether all the hazards are covered by the harmonizing reference standards. And if the answer is no, well, then you need to risk manage. You might even need to do the EC type examination. That would be the normal procedure if you know that there is a hazard not covered by a standard. But if the answer is yes, there's still one thing you should check, at present, we don't have any notices published from the European Commission restricting the presumption of conformity of the standards. But historically, there have been cases where the Commission has published a notice saying that for a specific part of the standard, it is not deemed to give presumption of conformity. But if there are no such, well, if there is, then you need to act. But if there are no such notices, well, then you're okay. You can place the toy on the market. So this would be a flow chart of how to perform the safety assessment for mechanical, electrical, and flammability hazards. And I would say this is rather easy in comparison to, for example, chemical hazards. I will now use some example internally from the LEGO group, because also when we, as manufacturers, have established that, well, through the risk assessment or safety assessment, that all hazards are covered, we might still consider to go further than what the standard requires. And within LEGO, we have, for example, for our Duplo range, those are the larger bricks and larger toys which are intended for children from 1.5 years and up, meaning that they can contain no small parts. They have to be safe for all age groups. Instead of using only the normal small parts cylinder, we have designed another cylinder, which is in fact slightly larger, just to be sure that we are in fact way above. So you could almost say that this cylinder fits in the larger cylinder. So it's 36.4 millimeters. Now, I'm not saying everybody has to do this. It's an internal decision. We have taken that decision. The legal requirement is only to use a small part cylinder. We have another template. It's a 1.5-inch template. And we use this for items that we know children like to put near their mouth, like figurines, food-like items, animals. They must not fit in this template or pass through this template. And you can see how we've tested a figurine or a part, a removable part of a toy animal. Other examples where we have taken internal decisions to reduce the risk further than what's required with the standard. In the picture is a flame. Also in the Duplo range, it's got a hole here so you can actually attach it to the knobs of the Duplo bricks. It's molded in a flexible material because we don't want it to be a projection hazard. But if you look closely at the picture, you'll also see that it's molded with an intended bend so that when pressure is applied, we know that it always bends in that direction. Because if it was molded in a soft material that was pointing right up, that could still be a risk. So we've tried to avoid that risk by molding it in that way. Another example is a little umbrella, also from the Duplo range. We did, a long time ago, receive a report from a consumer that their child had managed to put this in the ear and actually penetrate the eardrum. There's nothing in the standards to protect children from penetrating the eardrum, but we chose to introduce a little collar around, and the measures of the collar and the distance from the end is agreed together with an ear doctor. I don't know the medical name for it, a doctor specialized in ears, and this will ensure that the child cannot penetrate the eardrum. So that's another example of how you, as a manufacturer, can use your safety assessment to actually go further than the standards require, because we don't want, nobody wants their products to hurt children. We will now move on to the hygiene and radioactivity hazards. We have already concluded that we do not have harmonized standards in Europe for these hazards. Now, the hygiene hazards could be either microbiological hazards, that's toys that contain liquids or are aqueous-based or contain natural materials like pips or nuts. And it could also be hazards linked to the possibility to clean and wash the toy. So microbiology and cleaning and washing. Radioactivity, I think it's so far unheard of in toys. So unless you've actively added some radioactive material, it shouldn't be a concern. But you know, we need to maintain or retain the present situation where it isn't a problem. And of course, you need sometimes to consider whether the materials you source could be contaminated, although I think it's very unlikely. And as mentioned in the beginning of the presentation, there is no explicit expectation that these toys that could present hygiene or radioactivity hazard must be submitted to an easy type examination to verify that these hazards are not present. It can be dealt with in your safety assessment. So if we look further into microbiological hazards, the requirement of the Toy Safety Directive is displayed. It says that toys must be designed and manufactured in such a way as to meet hygiene and cleanliness requirements in order to avoid any risk of infection, sickness, or contamination. And microbiological contamination would refer to the presence of, for example, bacteria, yeast, mold, fungi, etc., or byproducts, which could have an effect on the consumer's health. And in order to deal with this risk, if the toy is liquid or aqueous-based, like paint, modeling clay, etc., or if you're using natural materials, you need to evaluate these toys for the presence of microbiological contamination. And this requires some type of testing. One possibility is to use a protocol that the notified bodies of Europe have agreed on. It's called Microbiological Safety of Toys Containing Aqueous Media. And at the bottom of the slide is a link where you can find this document. But you could also use methods described in the European Pharmacopoeia or in the US Pharmacopoeia. And also in the ASTM standard, you have recommendations for microbiological testing. When it comes to cleaning and washing, well, we have a complex requirement in the Toy Safety Directive. But basically, it says that if the toy is intended for children under 36 months, it has to be possible to clean. And before and after the cleaning, it should still fulfill the safety requirements. And if it's also a textile toy, still intended for children under 3, but a 100% textile, it must also be possible to soak wash, unless it contains, for example, an electronic component or some other component that could be damaged when soak washed. So how can we deal with the safety assessment of these products? Well, the first thing would then be to ask ourselves, is the toy intended for children under 3 years? And we have learned previously that this is not only what the manufacturer decides to mark the toy with, it actually has to be reasonable also for the consumer to understand that this toy is intended or not intended for children under 3. Well, if it's not intended for children under 3, it's not covered by the requirement. Is it a textile toy? That's the next question. If it's not, well, then the cleaning requirements applies. And if you wish, as a manufacturer, you could add cleaning instructions. If you feel that it's important to tell the consumer how to clean your product, you can include instructions. If it is a textile toy, well, then you need to ask yourself whether it contains a mechanism that can be damaged by soak washing. And if it doesn't, well, then you need to make sure that it can be soak washed. And again, you might want to add instructions. If you want to avoid that the consumer washes the toy in 90 degrees, tumble dry, etc., you might want to say only hand wash 30 degrees, if you feel that it's important for the safety of the toy. And if it does contain a mechanism, well, then you're only covered by the cleaning requirements. So again, the process is reasonably simple. I should perhaps add that soak washing means immersing in water or some other liquid. It does not necessarily mean machine washing. So hand wash is okay. And now the cleaning is difficult perhaps to see why cleaning would reduce the safety of the toy, but washing could. I mean, washing could perhaps cause ice to come loose of a soft fill toy easier. It could perhaps be that the toy could soak up water, and you need the possibility to drain the toy in order to reduce the risk for contamination. Now, we'll move on to the chemical section, and I think in order to understand this, we need to have a very quick look at the chemical requirements that will apply from the 20th of July 2013. After all, that's quite soon. First of all, we have a general ban on CMR substances. That's carcinogenic, mutagenic, and harmful to reproduction. They should not be used in accessible parts of toys. But there is a derogation saying that in our regulation for classification, labeling, and packaging of dangerous substances and mixtures, we have certain concentration limits, and you are allowed to use these substances provided that they are below those limit values. There are also some derogations if you use food contact material, it's graded as food contact material, or there is also an appendix to the directive in which certain substances can be listed. At present, nickel is listed as permitted to use in stainless steel, although it is a CMR substance. We have a list of 55 allergenic fragrances that shall not be used over trace levels, and there are another 11 fragrances which you can use, but you need to have special marking on your product. A cosmetic toy must fulfill the requirements of the Cosmetics Directive. We have migration limits for 19 substances, and they apply to 3 different material categories: scraped off material, dry and brittle material, and liquid material. And finally, we have a ban on nitrosamines in toys intended for children under 3, and also toys intended for mouthing. We have some low migration limits that apply here. So these are the basic requirements that we need to refer to. And we know, for example, that standards will not be available to test for CMRs. We have thousands of CMRs. It would be impossible to have standards for testing all of them. And we're not expecting to have standards in place for testing of fragrances. So here we definitely need the safety assessment. But a major part of the chemical safety assessment is to assess the likelihood of the presence of prohibited or restricted substances. That's the major part, but you also need to go further. You need to check also other substances. Let's say we call these substances undesirable in toy. Not regulated, but undesirable. We need to deal with those too. So a chemical safety assessment must consider all the applicable regulations and directives. We know that we have the Toy Safety Directive, but that also refers to any other legislation in Europe. We have the REACH regulation, we have a directive for restriction of hazardous substances in electric and electronic toys. It's actually covering any electronic product, but toys are also covered, and you need to be in control of those regulations as well. I have made a slide illustrating the ideal conditions. I don't think anybody fulfills them, but still, this is perhaps in the direction we should aim. We would like to have a bill of materials that includes only approved and traceable materials. That's a material with a trade name so that you know that you're sourcing exactly the same material all the time. And these are sourced from trustworthy suppliers. We would like to have a bill of substance available for all materials so that we know exactly which substances are present. And we would like all these substances to have been evaluated and found to not exceed any concentration limits or migration limits in the applicable standards or regulations. And we do not want these, or we have evaluated them so we know that they do not present an inherent hazard if the user can be exposed to them. We do not want to change the bill of materials or the bill of substances on a frequent basis. And we want the test reports clearly linked to the individual items. We had an example before of a test report for one teddy bear, but it's proved to exist in 100 different versions. So you need to have test reports clearly linked to the individual items. And then you need the safety data sheets for the chemicals that have been used in the production when required by REACH. If we have all this, we have a very good basis for our chemical safety assessment. The further away we move from this situation, the more difficult it will be. But the guidance document that's been published by the European Commission does give us an approach to the chemical safety assessment. It's divided into 3 stages. It's identification, characterization, and assessment. Where during identification, that's when you identify which substances, which materials to use. In the characterization stage, you will determine whether they are covered by the restrictions and standards that are in place, or whether they are suspected to be hazardous, or if they, let's say, undesirable. And in the third stage, that's when you assess the likelihood of the product containing more than the permitted amounts, or amounts that would mean a risk, although they are not restricted, could mean a risk when you consider the hazard and the exposure. At the identification stage, how do you identify the substances and materials? Well, you need the bill of materials. That's a basic requirement, and it's also a requirement for your technical documentation to have a list of the materials used. But the bill of substances is not a legal requirement, but it's desirable to have it because it's very difficult to perform a safety assessment of chemicals, hazards, unless you know what substances you're using. And usually it would be available for formulated mixtures and for polymers like plastics, but ink, glues, etc. I also mentioned the SDSs when REACH requires an SDS. I think a link was given in the presentation made by Mrs. Logge. And then also you need to note where the material is used, because when you later will be assessing exposure, you need to know, for example, if there is prolonged skin contact. That means that, for example, nickel allergy requirements would be applicable. We have some requirements for azo dyes. That again depends. Is it mouthable, etc. So you need to document that. But what happens if you only have limited information, if you do not have the bill of substances? Well, you can make worst-case assumptions. We sometimes talk about where-used data. We know, for example, that if you have a soft PVC, it's likely that it's been softened or plasticized with phthalates, and some of those are prohibited. So that would be a natural assumption to say, well, before I know more, I will assume that the plasticizer used is one of the prohibited phthalates. You can also discuss with your suppliers to get declarations on specific substances where they guarantee that they haven't used them. That is, the best alternative is, of course, if they declare what they have used rather than what they have not used. But this is at least better than knowing nothing. We move on to the characterization stage, and the first question there is whether it's in the scope of the legal restrictions. And if you have the CAS numbers, that's the chemical number for the substance, you can use it to check whether the substance is classified as a C, M or R substance. I will later show you exactly how to do that. You can check whether it's one of the forbidden fragrances. You can check whether it's subject to REACH or ROS or other regulations or legislation. Second question, is it in the scope of standards? We do have a standard EN 71.3 for migration of certain elements. We have a standard 71.9 for organic chemical compounds. It hasn't been referenced by the European Commission, but it still gives you a very good picture of certain chemicals and how you could or should use them. In case you produce chemical experimental sets or chemical toys or finger paints, we have some specific standards for those, 71.4, 5 and 7. The third question is, Could the substances used be suspected or undesired? When you check classification for C, M or R, you will also learn whether they might be classified for some other health effect. Could be toxic, skin irritant, etc. You can use that information in your assessment. You can also check NGO lists. There are several various NGOs that will list substances that they feel are of concern. You can look at industry association information. Again, you can check RAPEX notifications, etc. All these sources should be used in order to assess whether you're using substances that are not regulated but of concern. So we've identified and characterized the substances and materials, and we then move on to the assessment. Here we have two cases: substances that are prohibited and restricted, or the ones which are not yet prohibited or restricted. For those prohibited and restricted, we need to know whether the limit values are exceeded. We have confirmed that a substance is covered by regulation. Now we want to check whether it's exceeding any limits. And here we have various regulations. Some will be for total concentration, others will be for migration. So we need to differ between these two. And again, if we do not have a bill of substances, well, we need to use our where use data from the identification stage. Perhaps we have assumed that a certain material has been treated with a certain substance. And we will then need to, if the worst case assumption shows us that it's not compliant, well then we need to test to confirm whether we in fact do have that substance in our product. As far as possible, in order to reduce costs, you can assess and assume until you know whether that assumption leads you to a non-compliant situation. Then you need to apply the testing to ensure. The second case were the substances which are not prohibited but could be present in amounts that could mean a risk, considering the hazard and the exposure. Here we have two categories again. One is, I mentioned that there can be other classifications than CMR, and if they are classified for other health effects, well then you need to assess the exposure and hazard to conclude the risk. And again, the possibility here is to use industry data, but you also need to check the information you have on the age of the user, the way it's used, whether it's ingestion risk, inhalation risk, a dermal risk, etc. And if we lack data, again, we can use experience from industry. We can assume a worst case. For example, we will assume that 100% of the substance is migrating. If we are okay after that assumption, we don't need to do more. But if it shows us that in that case we have a problem, then we can do a test to check the actual migration. If it's not classified in CLP, then again you will have to use experience, NGO lists, and suddenly a debate will evolve over a certain substance in media, and you come to a point where you realize that you will need to manage if you're using that substance. This is a quick summary of the LEGO Group's approach when it comes to resins, inks, glue, lubricants, etc. We try to obtain the supply name, the trade name, the CAS number, and the percentage used of all substances. We require to see the recipes for everything that goes into our core line products. We check the classification. We check the specific concentration limits in the CLP regulation. And unless we have already internally banned it, we will then check limit values. We will check if it's classified as something else than CMR and then define the risk. We will check REACH Annex 17. We will check the ROS Directive if it's applicable, fragrances, nitrosamines, EN 719, databases, the list of substances of very high concern, any NGO lists, and we'll also run an automated toxicological assessment through a tool that's called Cyvera Lens. It's an American company that supplies this. And of course, the meaning of this is to never be surprised when we test the finished product. by ascertaining that everything that goes in is okay, we know that the final product will always be okay. Finally, I just want to show you exactly how you use the CLP in order to check the classification. You need a CAS number for your substance. You can find that on this link by entering the substance name. You will receive the number. And then you use table 3.1 of the regulation in Annex 6, and there again you have a link to find that. And when you enter this, in this case I've used benzoapyrene, which is polyaromatic hydrocarbon, and I've drawn 3 arrows to show that this is clearly classified as a carcinogenic class 1B. We have class 1A, class 1B, or class 2, the 3 classifications. It's mutagenic and it's also harmful to reproduction. But in addition, there is also a specific concentration limit at the far right column. This means that for this substance, it's not enough to fulfill only the limits that are given for the various classes 1A, 1B, and 2. No, you also need to fulfill the specific concentration limit, which in this case is 10 times lower than the generic limit given by the classification. And those generic limits are also specified in the CLP, and this is an example of the generic concentration limits for carcinogenic substances. So if it's a 1A substance, you can use it up to 0.1%, and if it's class 2, you can use up to 1% of it. So these are the limits that you have to comply with for the CMR substances. Basically, you don't want them in your toys. But if for some reason there's contamination, these are the limits to comply with. When do you need to update your safety assessment? Well, if you make any changes to the product that could affect the safety, if there are changes in standards, in the regulations, new scientific information comes available, if you receive consumer complaints, if you see that similar toys are recalled, etc. These are cases when you might need to change or revise your safety assessment. But if nothing changes, you concentrate instead on keeping your production in control so that you know that every product produced is as good as the ones that you have, let's say, type approved. And finally, I'll just conclude that for the future, it's going to be more and more important that you collect as much information as you can on what goes into the toys, and that you're willing to share those with your European customers, because they will also want to know and need to know that they comply by knowing what's in their products. So thank you very much.